Hi everyone, let's see the topic of auto transformer starter. These starter are also called as auto starters or compensators. It consists of an auto transformer with necessary switches. This method used for both star and delta connected motors. Reduced voltage for starting can be obtained from three auto transformer connected in star. If the voltage is reduced to a fraction of the rated voltage, the motor starting current is IST equal to X into ISC. The tapping on the auto transformer is so set that when it is in the circuit, 65% to 85% of the line voltage is applied to the motor. At the instant of starting, the changeover switches is thrown to start position. This puts the auto transformer in the circuit and reduced voltage is applied to the circuit. Consequently, starting current is limited to safe value. When the motor attains about 80% of normal speed, the changeover switch is thrown to run position. This takes out the transformer from the circuit and puts the motor to full line voltage. Auto transformer starting has several advantages via low power loss, low starting current, and less radiated heat. For large machine over 25 horsepower, this method of starting is often used. The auto transformer may be either manually or magnetically operated. Come, let's go with relation between starting and full load torque. Consider a start connected squirrel cage induction motor. If V is the line voltage, then voltage across motor phase and direct switching is V by root 3, and starting current is IST equal to ISC. In case of auto transformer, if a tapping of transformation ratio K is used, then phase voltage across motor is maintain IST equal to X into ISC. It should found that starting torque is reduced to a fraction of that obtainable by direct starting. The starting line current is also reduced by the same fraction. Compared to the primary resistor starting, the line current reduces further a fraction X while torque remains the same. The auto transformer starting is much superior to primary resistor starting. Also, smooth starting and high acceleration are possible by gradually raising the voltage to the full line value. Next is star delta starter. On the start winding of the motor is designed for delta operation and is connected in star during the starting period. When the machine is up to speed, the connections are changed to delta. The circuit arrangement for star delta starting is shown in figure. The six leads of the starter winding are connected to the changeover switch as shown. At the instant of starting, the changeover switch is thrown to start position, which connects the starter winding in star. Therefore, each starter phase gets V by root 3 volts, where V is the line voltage. This reduces the starting current. When the motor picks up speed, the changeover switch is thrown to run position, which connects the stator winding in delta. Now each stator phase gets full line voltage V. It has some disadvantages that or with start connection during starter phase voltage is 1 by root 3 times the line voltage. Consequently, starting torque is 1 by root 3 of square or 1 by 3 times the value it would have the delta connection. This is rather a large reduction in starting torque. The reduction in voltage is fixed. So this method of starting is used for medium size machine up to 25 horsepower. Relation between starting and full load torque in direct delta starting, where IAC starting phase current in delta, IF full load phase current in delta. Note that in star delta starting, the starting line current is reduced to 1/3 as compared to starting with the winding of delta connected. Further, starting torque is reduced to 1/3 of that obtainable by direct delta starting. This method is cheap but limited to applications where high starting torque is not necessary. Example, machine tools, pumps, etc. It is clear that the star delta starting reduces the starting torque to 1 to the third that obtainable by direct delta starting, and also the starting line current. The star delta starter is equivalent to an auto transformer of ratio of 1 by root 3 or 58% of tapping approximately. Then starting of slip ring induction motor, rotor rheostat starter or rotor resistance starter. The slip ring motor are practically always starter with full line voltage applied across the stator terminals. The value of starting current is adjusted by introducing a variable resistance in the rotor circuit. The controlling resistance is in the form of rheostat connected in star, the resistance being gradually cut out of the rotor circuit as the motor gathers speed. By increasing the rotor resistance, only the motor current is reduced at starting, but at the same time torque is also increased due to improvement in power factor. The rheostat is either of stud or contactor type and may be hand operated or automatic. The introduction of additional external resistance in the rotor circuit enables slip ring motor to develop a high starting torque with reasonable starting current. Hence, such motor can be started under load. When the motor runs under normal condition, the rings are short circuited and brushes will be automatically lifted from them. Slip ring motor are invariable starter by rotor resistance starting. In this method, a variable star connected rheostat is connected in the rotor circuit through slip ring and full load is applied to the starter winding. At starting, the handle of rheostat is set in the off position so that maximum resistance is placed in each phase of the rotor circuit. This reduces the starting current and at the same time starting torque is increased. As the motor picks up speed, the handle of rheostat is gradually moved in clockwise direction and cuts out the external resistance in each phase of the rotor side. When the motor attains normal speed, the changeover switch is in the on position and the whole external resistance is cut out from the rotor circuit. Slip ring induction motor versus scroll cage motors. The slip ring induction motor have the following advantages over the scroll cage motor. One is high starting torque with low starting current, smooth acceleration under heavy load, no abnormal heating and during starting. Good running characteristics after external rotor resistance or cutout, adjustable speed. It has some disadvantage of slip ring induction motor. The initial and maintenance costs are greater than those of screw cage motor. The speed regulation is poor when run with resistance in the rotor circuit. Then soft starter. A soft starter has different characteristics to the other starting methods. It has thyristor in the main circuit and the motor voltage is regulated with the printed circuit board. The soft starter makes use of the fact that when the motor voltage is low during start, the starting current and starting torque is also low. The soft starter eliminates unnecessary jerks during the start. Gradually, the voltage and starting torque increases that the machinery starts to accelerate. One of the benefit with this starting method is the possibility to adjust the torque to the exact need, whether the application is loaded or not. In principle, the full starting torque is available, but with the big difference that the starting procedure is much more forgiving to the driven machinery, with lower maintenance cost as a result. Another feature of the shaft starter is the soft stop function, which is very useful when stopping pumps where the problem is water hammering in the pipe system. A direct stop is for star delta starter and a direct online starter. The soft stop function can also be used when stopping conveyor belts to prevent material from damage when the belt stops too quickly. Soft starting an AC motor refers to any one of several starting methods that limit the starting current and the torque of the motor. The reduced voltage starter and will be referred to as soft starting. Soft starter use voltage control to limit the motor starting current and the torque by continuously ramping of the applied motor voltage when starting and stopping. Other reduced voltage starting technique causes step change in the applied motor voltage. using electromechanical contactor switching. Soft starting an AC motor refers to any one of several starting methods that limit the starting current and the torque of the motor. The reduced voltage starters and will be referred to as soft starting. Most soft starter use voltage control to limit the motor starting current and torque by continuously ramping the applied motor voltage when starting and stopping. Other reduced voltage starting techniques cause a step change in the applied motor voltage using electromechanical contactor switching. Thank you.